multiple phases. It means where the species get transferred from the one phase to another phase. The true driving force is chemical potential difference. Clear? So it is a driving force. Means when the more the driving force, more the rate of mass transfer will be. Means rate means what? In a given time, through given area, more the species will get transferred. That's called rate or flux, you can say also. So actually the rate is in a given time, the amount of species that get transferred is called a rate. But if flux in a given time through a given area, the amount of species get transferred is called as rate, flux sorry. The rate per unit area is called as flux. Clear to you? I already told you in the heat transfer. In the difference between what is a flux, what is rate. So that is what driving force. So as you can see, the driving force is, suppose I am talking about the transfer of energy in single phase. Suppose if you have a glass and here you have put the sugar cube, glass of water is there and here sugar cube is there. That's a sugar cube. Obviously, the driving force is there. Why? Because the concentration as far as its single phase mass transfer is there. Why? Because the transfer of species of sugar molecules is only from only in the liquid phase. Because if you see here, whatever the water molecule near the surface of sugar cube will be saturated. Yes or no? It is sugar cube is there. Then if you observe any water molecule which are surrounded with the which surrounds the sugar cube will be saturated, and any water molecule which is far from this sugar cube surface will be unsaturated. It means the concentration of sugar molecule in the water near the sugar cube is more as compared to the concentration of the sugar molecule in the water far from the surface. Means let's say this is the one location, this is second location. In these two locations, the two water surfaces are there. In two water surfaces or in the two water levels, the concentration of sugar molecule is different. Why? Because the water molecule which are just on the surface of sugar cube will be saturated. So that is the here driving force is difference in concentration. More the difference in concentration, more will be the mass transfer operation. But it is only driving force. And suppose if you have replaced the sugar cube with the stone, what happens? If you replace the sugar cube with a stone, then what happens? If you replace the sugar cube with the stone, then what happens? So in this case, obviously there is no driving force is there. Why? Because even the water surfaces, water molecules which are near the surface of solid, they have same concentration as the water far from the surface. Why? Because there is no solubility of stone in the water. Yes or no? Means the molecules which have to be diffused in any medium that must have solubility for this. Yes or no? Please tell me. So is this clear now? Why I told you in the single phase driving force is concentration difference, in multiple phases driving force is chemical potential difference. Reason is that because listen, I will discuss through very simple example. Suppose you have a container and in this container you have water is there. This is half filled with water, and what you did here, you have just injected the air ammonia mixture, air plus ammonia mixture in a gas phase. There is a liquid phase and there is a gas phase. Clear, air ammonia mixture is there. As you know कि ammonia, water has some solubility for ammonia, means ammonia can be dissolved into the water to some extent, but air is insoluble in the water, that you know very well. So ammonia molecules, as the two phases, gas phase and liquid phase, allowed to be in contact, there is a formation of interfaces there. This is called an interface. What interface? Where the two phases are allowed to be in contact. Clear? Just we can, a simple example is there. You have water half filled and you have just injected the air ammonia mixture. Then since ammonia can dissolve into the water, then ammonia molecules, some of the molecules of ammonia will get penetrate into the water surfaces and enter into the water, and at the same time some of the ammonia may also get transferred into the further gas phase. So ammonia, but the net transport of ammonia, because you know the molecules are very random in the nature, so some molecules will get transferred into water and some ammonia from the water also get transferred into the gas phase, but the net transport is from gas phase to liquid phase. The net transport of ammonia is from the gas phase. Net means suppose 100 mole will get transferred, then only 2 mole will get out. If 100 mole, let's say if 10 moles of ammonia will get entered into the water, then 2 mole ammonia will get out from the water because of its nature is there. So ultimately the net 8 mole will get absorbed into the water. Yes or no? So as the time progresses, if you keep sufficient time, if you keep this mixture for sufficient time at the given temperature and pressure, then what happens? The concentration of ammonia in the water in the liquid phase will get increases. Yes or no? Because now previously the water was pure, but when you allow it to be in contact with the air ammonia mixture, then the ammonia will get dissolved into the water, and that is the reason why the concentration of ammonia will get increases into the liquid phase, and the concentration of ammonia will get changes till the equilibrium will established. What is equilibrium? Here I am talking about chemical equilibrium, because temperature and pressure is constant. It means the system is already in thermal and mechanical equilibrium. It is only non-equilibrium in respect of chemical equilibrium, chemical non-equilibrium. But when the chemical equilibrium is established, then how you can say the chemical equilibrium is established? You might have seen in the solution thermodynamics. Two phases will be in chemical equilibrium if the chemical potential of species in all phases will be equal. Yes or no? As long as there is difference in chemical potential of the species in the two phases, there is always transport of species will continue. Yes or no? So what happened here? Since ammonia can dissolve into the water, then concentration of ammonia in the water will get increases, and at the same time concentration of ammonia in the gas phase may also change. So this change will continue till the system reach to the chemical equilibrium, because once the equilibrium is established, I told you there is no macroscopic change. The definition of equilibrium is what? There is no any observable change at the macroscopic level. It means the rate at which once the equilibrium is established, the rate at which the ammonia will get transferred from the gas to liquid, same rate ammonia will get transferred from the liquid to gas. It means there is no net change, no further change in the concentration of ammonia in the water phase and in gas phase and liquid phase. So as long as the concentration of ammonia in the gas and liquid phase is changing, it means the process is not in equilibrium. But if you keep sufficient time and keep monitoring, it means you are taking the sample at each and every time interval, and you are going to measure the concentration of ammonia in the gas phase as well as in the liquid phase. And if you find no further changes found in the concentration of ammonia in the gas and liquid phase with respect to time, that means the system has been reached to the equilibrium. Clear to you? So I am not saying that concentration will be equal. I have not told you. I have told you concentration will be constant differently in the gas phase and liquid phase. I will give you a point. At the given temperature and pressure. So at the given temperature and pressure, let's say what I am saying to you, if you allow for sufficient time, then at the given temperature and pressure, here air plus ammonia, here water plus ammonia is there, yes or no? In this case, let's say concentration of ammonia, I am saying here YNS3 in gas phase, and here I am saying XNS3. X for liquid phase, Y for gas phase. And here I am star. Star means equilibrium values. Star indicates you equilibrium composition. So they are equilibrium compositions. Why? Because these are the values which are not going to further change with respect to time. Means that will remain same as long as temperature and pressure is constant. Clear to you? It means, let's say this is 0.2 and this is, let's say, 0.1. It is not necessary to be equal. Are you getting the point? But they are not going to further change with respect to time. That's what is called as equilibrium. So in the equilibrium, it is not necessary that the composition of the species will be equal. But I can say that at this concentration of ammonia in the gas phase, the chemical potential of ammonia in gas phase will be equal to the chemical potential at this concentration of in liquid phase ammonia will be equal. Although composition is not same, but at this concentration the chemical potential of ammonia in the gas phase and at this concentration chemical potential of ammonia in the liquid phase will be equal. Once it will be equal, it means that is the condition for phases to be in equilibrium. It is clear. If you recall, in solution thermodynamics we have discussed that the multiple phases is said to be in equilibrium at the given temperature and pressure if the chemical potential of a species, each and every species, will be found to be equal in all phases. Yes or no? So here, that's why in this case the transfer of ammonia is there from the gas phase to liquid phase. Net transfer is from gas phase to liquid phase. Is this clear? So that's why I told you in multiple phases the driving force is chemical potential difference. Why? Because even though the difference in, you can see, if suppose we have assumed the concentration difference will be driving force. If the concentration difference would be the driving force, if concentration difference would have been the driving force, then what happened? There should be mass transfer because this is 0.2, this is 0.1, there is difference in the concentration is there. But in this case, at this concentration of ammonia in the gas and this concentration of ammonia in the liquid phase, there is no mass transfer is there. Why? Because the system has been reached to the equilibrium. And at this concentration, the chemical potential and at this chemical potential of ammonia in the gas and liquid phase is found to be equal. That's why, although there is a difference in the concentration is there, but there is no difference in chemical potential. That's why the true driving force for the mass transfer in multiple phases is what? Chemical potential difference. Clear to you? Yes or no? So equality equality of, and even it may be also possible कि concentration difference, concentration of the ammonia in the gas and liquid phase may be equal, but still the system will be non equilibrium. Why? Because the driving force is not the concentration difference. Driving force is chemical potential difference. So as long as there is a difference in the chemical potential of a species in the multiple phases, there will be transfer of that species. And once the chemical potential of the species in the all phases is going to be equal, there is no further transport of that species will be taken. Clear to you? Now is this clear? But as far as single phase is concerned, there is no issue. You can see directly the difference in concentration in the driving force. क्लियर है भाई? So this is what I told you about the driving force. Now come to the types of mass transfer. There are following two types of one is molecular mass transfer and another is convective mass transfer. Molecular mass transfer and convective mass transfer. So molecular mass transfer is by the due to molecular diffusion. And this is due to molecular diffusion. And this is due to eddy diffusion. Convective mass transfer is due to eddy diffusion and molecular mass transfer is due to molecular diffusion. What is molecular diffusion? First I would like to start molecular mass transfer. Molecular mass transfer. As the name suggests, it's a molecular phenomenon. It means the transfer of a species at the molecular level due to only molecular activities. So molecular mass transfer is due to molecular diffusion. And it is the mass transfer which are taking place at the very low rate. It is very slow. So as far as I told you, molecular mass transfer is due to molecular diffusion. Then what is molecular diffusion? First of all, what is the difference in mass transfer and molecular diffusion? There is always some confusion. The molecular diffusion is nothing. It's simply the movement of molecules through a substance by the virtue of their thermal energies. You know, the random. If I'm talking about the in a room, some gas particles are there, and these gas particles are moving randomly. So this random movement of the molecule is called as molecular diffusion. It's not a mass transfer. If suppose in a room, I told you now, in a room, or suppose you are talking about the water molecules. So as water molecules, if the water is there, then water molecules are moving randomly. The random motion of water molecule is not the mass transfer. It's called as diffusion. So diffusion word is just by diffusion words is for random movement of the molecules. And obviously, if any molecules are moving either in the liquid or in gas phases, that's because of some energies to be there. So that's what is called as molecular diffusion. The molecular diffusion is the movement of molecules through a substance by the virtue of their thermal energies. So every molecule has some thermal energy, and due to this thermal energy, this kinetic energy is there, and due to this kinetic energy, the molecules are moving randomly. And that random motion of the molecule is called as molecular diffusion. And if this random motion of the molecules are taking place under the concentration gradient, that's called as mass transfer. Clear to you? So I would like to discuss here molecular mass transfer is due to molecular diffusion. And now, what is molecular diffusion? Then please come to the topic here, molecular diffusion. Please correct spell molecular diffusion. So molecular mass transfer is due to molecular diffusion. Then question is, what is molecular diffusion? Molecular diffusion is nothing, as I told you. It is a molecular diffusion is concerned with the random movement of the molecules through substance by virtue of thermal energy of their thermal energy. So molecular diffusion is due to thermal energy, not due to difference in concentration, because it's a random movement of the molecules. So what is the molecular mass transfer? If the molecular diffusion is taking place under the difference in concentration, it means if this random movement of the molecules are taking place from the region of higher to lower concentration, that is called as molecular mass transfer. Is this clear? And if this random movement of molecules are taking place from region of higher concentration to that of lower concentration is called as molecular mass transfer. So mass transfer is different thing. Mass transfer is transport of the species from the region of higher to lower concentration. But if so that transport from the higher to lower is taking place either via molecular diffusion or through eddy diffusion. If it is taking place through eddy diffusion means because of random motion of the molecules, that's that transport of the species which are taking place due to random motion of molecules from the region of high to low, that's called as molecular mass transfer. Clear to you? Otherwise, everywhere the random motion of molecule is there. But if suppose you have burned an agarbatti in a corner of the room, now again the molecule of agarbatti will get random movement because of its thermal energy is there, some temperature is there, no? And you know very well that from the third law of thermodynamics, the molecules motion are only going to freeze at absolute zero temperature. Otherwise, the molecules are moving. So same thing here. If you burn agarbatti in the one corner of the room, then due to random motion of the molecules, there is a diffusion is there. But if this diffusion is taking place from the region of high to low, that's called as mass transfer. Clear? And as far as molecular diffusion is concerned, molecular diffusion is very slow process. Molecular diffusion is very slow process, because if diffusion is slow, then obviously if suppose you have burned agarbatti and the movement of agarbatti or random motion of the molecules of agarbatti is very slow, then obviously the rate of mass transfer will also be slow. So if molecular diffusion is slow, then mass transfer rate will also be slow. Why it is slow? Thus I want to define here. Because by kinetic theory of the gases, a molecule is imagined to travel in a straight line at uniform velocity until it collides with other molecules. So just please, by kinetic theory of gases, a molecule is imagined to travel in a straight line at uniform velocity until it collides with other molecule. Whereupon, as it collides, its velocity changes both, because velocity is vector quantity, its velocity changes both in magnitude and direction. Clear? So, as far as kinetic theory is concerned, the kinetic theory says the molecule is imagined to travel in a straight line at uniform velocity until it collides, and once it collides with other molecules, its velocity changes in both magnitude and direction. And since the molecules changes its velocity both in magnitude and direction, the average distance the molecules travels between the collision is a mean free path. What do you mean free path? The average distance the molecules which travels between the two successive collision is called as mean free path. And you know very well the mean free path is strongly dependent upon the temperature and pressure. And since the molecules are moving randomly and they will go to collide with other molecules and they change the direction, that's why the net movement, the net distance in one direction which it moves in a given time is only small fraction of the total actual path. And that's why the molecular diffusion is a very slow process. So as I told you, the molecules are going to collide with other molecules, and the distance which has been traveled between the two collision is called as, between the successive collision is called as mean free path. So continuous due to continuous collision, for example, try to say if this is molecule, you might have it is similar to the Brownian motion. Let's say this is the molecule is there. That molecule we have observed. This molecule travel randomly in this direction, and once it is moving here, it will collide with other molecules, and once it's collided with change its direction here, and again it move here, again it may move here, again it will move here. So what you have seen here, if you track its path, so what you have seen in a given time interval, the net distance starting from initial and this is final. The net distance which has been traveled is only small fraction of the actual distance which has been covered. The actual distance is from here to here, then here, then here, then here. But if you talk about the actual displacement, actual distance which has been traveled of the molecule from the its initial to final position is very small fraction of the total actual distance. Yes or no? It's only small fraction actual. Start here हुआ, finally यहाँ पहुँचा. Why? Because continuous collision is there. As it start moving, collide with the molecules, and upon collision, the molecules will change its velocity in both magnitude as well as in direction. That's why the net distance traveled by the molecules in a given direction is only a small fraction of the actual length which has been covered. Clear? You can write please. Hence, the net distance in one direction which it moves in given time is only a small fraction of its actual path. Yes or no? And that's why, because net distance is very small of the actual. That's why the diffusion, it means in the given time interval you have seen the molecule has only moved from a very small fraction, and that's why it is a very, very slow process. That's why molecular diffusion and hence molecular mass transfer is very slow process. Clear to you? Yes or no? And if you can imagine practically, suppose if you have a glass of water and if you put the sugar cube in the water such a gentle way so that no hindrance should be there, as long as much as possible you should avoid any hindrance in the water, and you place it will take very long time to dissolve the whole sugar. It may take 1 day or it may take 25 hours to become uniform concentration throughout. But if you take a spoon and agitate it, it will take hardly a second to make uniform concentration of the sugar throughout. Yes or no? So if you keep the sugar cube such a way that no hindrance in the water is there, it means you are going to inculcate what? Molecular diffusion or molecular mass transfer. It means any transport is only because of molecular phenomena. There's no any role of external agencies. Everything is going to happen molecularly at the molecular level due to random motion of the molecules. There's no any other external agencies are not going to involve. But if you're taking a spoon and agitate the sugar cube, then it will take hardly a second to make dissolve all the sugar and make the uniform concentration of sugar in whole water. Yes or no? And that's what is eddy diffusion. So eddy diffusion is when you're using the spoon. We create a hindrance, we create the eddies. And obviously that's why the convective mass transfer is very fast process. Because convective mass transfer it will do eddy diffusion. Is this clear? So why the molecular mass transfer is very slow? Because I told you, as for example in this case, as the sugar molecules are going to diffuse, then again it will collide with other molecules and it will change direction, and again it will collide, and in a given time interval it will only cover a very small fraction of actual distance which has been covered. The net movement in a given direction is very small, and that's why the rate of molecular mass transfer is very slow process. The question is that then how can I increase? Clear? So this is the reason why the molecular mass transfer is slow process. The question is that how can I increase? Method to increase the rate of molecular diffusion or molecular mass transfer. The two ways is there. One way, increase the temperature. And second one is decrease the pressure. What happens if you increase the temperature? By increasing temperature, you will increase the kinetic energy of molecules. Increasing temperature will increase kinetic energy of molecules. And obviously if the kinetic energy will increase, then obviously velocity of the molecules will increases. And if the kinetic energy will increases, it means in a given direction molecules will move a more distance in a given time. Yes or no? That was initially less. The net distance traveled by the molecule was very less, but in a given time interval. But if we are going to increase the temperature, then molecules have become more energetic and they will cover a more distance. It makes the molecule to cover more distance in a given time interval. And hence we can increase the rate of mass transfer. Now, what about this decrease in the pressure? How the decrease in pressure will increase the rate of mass transfer by the diffusion? When the pressure decreases, basically this is gases. As pressure decreases, what about the mean free path? As the pressure decreases, the distance between the molecules will get increases, or lambda you can say, lambda which is called a mean free path. Will increase, If the mean free path will increases, then what happens? Number of collision will decreases, and if the number of collision will decreases, and as you have seen, due to collision only the molecules have been changed its velocity both in magnitude direction. Now, as the pressure decreases, the lambda has been increased, means distance between the molecules will get increases. That will obviously increase the net distance traveled by the molecules in given time interval. Yes or no? Hence, molecules cover more distance in given time interval. In given time, clear to you? So there are two reasons is there. How can I increase the molecular mass transfer? One is by increasing temperature, and second is lowering the pressure. This is the way how can I improve the molecular mass transfer. But as long as temperature pressure is constant, you can't do anything else. Clear? So what is the main important point about the molecular mass transfer? So as far as molecular mass transfer is concerned, molecular mass transfer, the points about this is it is due to molecular diffusion, means random motion of molecules. Second, it is very slow process. It is very slow. Third is we can increase the molecular diffusion or molecular mass transfer by increasing the, we can increase a rate of molecular mass transfer by increasing temperature and lowering the pressure. Third is that prevails only in molecular mass transfer. You can expect only when the fluid is stagnant or moving. This can exist either in stagnant fluid medium, in stagnant fluid medium, or in laminar flow, in laminar flow. This molecular mass transfer phenomena you can only get observed in either the fluid is stagnant or when the flow is laminar. In laminar flow, I told you, in the laminar flow, the momentum transfer is by molecular phenomena, and that's given by the Newton's law of viscosity. Yes, sir? While in the turbulent flow, the momentum transfer is not only by the molecular phenomena but also due to eddy diffusion. Eddy will also come into picture. Yes or no? A similar analogy is there here. So when the flow is laminar, in the laminar flow, the fluid, there is no any transverse, only lateral displacement is there. One layer of molecule will move other layer, but there is no any transverse displacement was there in the laminar flow. So same thing here, if you are going to observe what are the areas where the molecular mass transfer can exist, the one area is where the fluid is stagnant. When the fluid is stagnant, Stagnant means, stagnant doesn't mean that there is no any movement of molecules. Just try to understand what is meaning of stagnant fluid medium. I would like to clear here. Stagnant fluid medium is, stagnant fluid medium means there is no macroscopic movement, no macroscopic movement, means there is no bulk motion is there. Means microscopically always, because as far as fluid is there, by fluid definition is what, there is always movement is there. You should not confuse the molecule or stagnant. No, actually the bulk is stagnant. Just like example of stagnant fluid medium is just a water is placed in a glass of glass. This is stagnant fluid medium. Why? Although the molecules are moving here, all molecules are moving. The molecular level, at the molecular level, always the movement of molecules is there. But as a whole, at the microscopic level, you have found no any movement in the liquid. That is called as stagnant fluid medium. So you can, the area of the field or area in which the molecular mass transfer prevails is stagnant fluid medium or in the laminar flow. When the flow is laminar, in the laminar flow also the mass transfer exists only by molecular phenomena. Clear to you? Just like I told you in the fluid mechanics, in the laminar flow the transport of momentum is only by the molecular phenomena, and that's given by Newton's law of viscosity. Clear to you? Similarly, in the stagnant fluid medium as well as the laminar flow medium, the mass transfer is only by molecular diffusion. Is this clear? Now, this is all about the basic information about the molecular mass transfer. Now, come to the convective mass transfer. The second mass transfer is, I told you two types of mass transfer is there. One is molecular, other is convective. This time I am going to start convective. Convective mass transfer. And I told you it is due to eddy diffusion or turbulent diffusion. And what it is, large chunk of molecules, large size of liquid molecules is called eddies. So when you are going to create eddies in the fluid, in that case, if the mass transfer is taking place, that because I told you that as the eddies will be generated due to agitation, due to turbulency, that eddies will also contribute more to the mass transfer, heat transfer, and momentum transfer. And the contribution of transport of the species, transport of the properties like mass or energy or momentum. The transport of the properties due to eddies will be much more dominate than the molecular. So in as far as collective mass transfer is concerned, the transport, or it is majorly due to eddy diffusion, although it is combined, but majority of the diffusion, majority of the transport of the species is due to eddies, because eddies will more contribute to the transport of the mass, heat and momentum. Clear? And obviously it is very fast process. Example is I told you, if you use a spoon to agitate whole, it will take very small time to get uniform concentration of the sugar in the water. sugar in a glass. It is very fast process, very fast, and it is generally takes place in turbulent flow medium. Clear better? So this is what the derivative mass transfer. I will discuss more detail about this. But first of all, I would have discussed here. So this is what is the molecular and kinetic. Now this clear, two types of mass transfer. The first is due to molecular diffusion, second is due to area turbulent diffusion. And kinetic mass transfer is very fast and it will prevail in the turbulent flow. Whenever flow is turbulent, then always the mass transfer is due to convective mass transfer. And it is very fast than the molecular mass transfer. Clear? So now this was a very basic introduction about the mass transfer. Now I am going to discuss here chapter 2, that is molecular mass transfer. The chapter 1 was only introduction, now chapter 2 is only for molecular mass transfer. Which is due to molecular diffusion. Now, before discussing about the mass transfer either through molecular or through convective, I would like to discuss a flux. What is flux? And types of flux. What do you know by flux? Anyone? The flux is defined as the amount of species that get transported, amount of properties. Properties may be mass, may be heat, may be momentum. So, properties that get transferred per unit area, per unit time is called as flux. It is defined as amount of, let's say here I'm talking about in mass transfer and species I will write here, amount of species get transported, get transferred per unit time through unit area normal to, area must be normal to direction of flow, unit area normal to direction of transport. So flux is defined as amount of species, how much amount of species has been transferred through unit time, through unit area normal to direction of transport. That's called flux. And the flux can also be defined as rate per unit area. Yes, flux is nothing, it's the rate per unit area. Because rate is amount of species that get transferred through unit time is called as flux, rate. And if the rate of species that get transferred through unit area, normal direction of transport is called flux. Clear? You can also define the flux as the rate of species that get transferred through unit area, normal direction of transport is also called as flux. You also define it is a rate of transport of a species, rate of transport of a species through unit area normal to direction of flow called as flux. Clear? So there are two types of fluxes there. One is called as Ni and another is called as Ji. Let's say I'm talking about flux of species I. So there are two types of flux. One is Ni and other is Gi. What is Ni? What is Gi? Ni is nothing, it indicates you the flux of species I. It is a flux and it's by molar mass, the flux of species I. So it's also the flux of species I. What is the difference in these two? It's also the flux of species I. The only difference is reference frame. So I stands for any species I. The two types of flux we have seen here to define the rate of transport of species. One is Ni, other is Gi. N and J. So Ni is nothing, it's a flux of species I with respect to a stationary observer or fixed location in space. And Gi is the flux of species I with respect to an observer which is moving with the average velocity. Means in one case, flux is what? Amount of a species which has been transferred through unit area, unit time. So in this, if you want to find the flux, the two types, the two method is there to measure how much species has been transferred from the one point to the point. One is when the observer who is going to count, who is going to measure how much species has been transferred, that observer is fixed at some reference point, fixed in some reference frame. And in other case, Gi, here again we are going to measure how much species has been transferred through unit area, unit time, but observer is not stationary. Now observer is moving with some average velocity. So in both cases we will get the two types of flux, two values of flux, yes or no? Are you getting a point? So now again, if you want to get more clarity about the flux Ni and Gi, Ni and here Gi, how can you clear it? Listen, Ni is the flux of species I, means how much amount of species I which has been transferred through unit area, unit time with respect to stationary observer, with respect to stationary reference frame. For example, suppose you as an observer, you stand on a platform and you are going to count how many trains has been passed in given time through unit area, in given area. Let's say this is what a railway track is there and you have just measured this area and you as an observer, you are here only. You are on the platform, and we're going to count how many in given area, how many trains has been passed in a given time. So that is also flux, because we are going to count. Let's say the species is now train. How many species has been transferred in a given time through a given area? That is what is Ni. Let's say I found if 5 trains has been passed in through 1 meter square area in 1 second, or let's say 10 second. 10 second. Clear? Then what is flux? 5 upon 10 upon 1. So it's 0.5 trains per meter square per second. This is what is flux, and that's called as Ni. Because in this case, the observer who is going to count, it is stationary. Yes or no? Because reference frame is important. With what reference you are going to measure the speed. And second is, again here railway, again the same railway track is there. Now although area is same throughout, but now the observer is moving on a bicycle. Observer is not standing here. Observer is moving with its bicycle like this. Now then he is going to count how many trains have been passed through unit area in given time interval. Now, but observer is not stationary. Observer is moving. Observer is moving with some reference, with some speed, some reference frame. Observer is not stationary on the reference frame. Observer is moving with some average velocity. Then he is going to count how many trains have been passed. In this case, obviously, they may get different numbers. Yes or no? So in both cases, what the difference is? Difference is the reference frame, the observer's position. Are you getting the point? It is very similar. Suppose you want to measure how many vehicles have been passed when you are standing on the bridge. You are standing on a bridge, and we are going to count how many vehicles have been passed in given time interval and given area. And in other case, you are also on a car, you are also moving with some speed in your car, and now you are going to count how many vehicles have been passed your car. So obviously the number will be different, yes or no? In both cases the number will be different, beta. That's why the two flux are there, Ni and Gi. I just want to clear more about the Ni and Gi. Suppose you and your friend plan to visit on a mall. In a mall, you have just visited to a mall, and on a mall you have found there is accelerator is there. Huh? Just try to understand. The accelerator is there. And you are away from the accelerator, you are not on the accelerator. You as an observer, you are not on the accelerator, you are away from the accelerator, and you are going to count how many person has been crossed, how many person has been crossed through unit area and unit time interval. That is other flux. And in another way, you are also on the same accelerator, now you are going to measure how many person has been passed. You, there is another number you will get, that is what is Ji. So Ni is the, so my dear student, in which types of flux, in which types of flux in which types of flux you are able to measure the ability of the species, in which types of flux you are able to measure more characteristic feature of the species. If you want to measure the, suppose I want to measure the species of I, so in which types of flux you are able to measure the characteristic feature of the species? Ni. In Ni, my dear student, suppose you want to, my dear student, suppose in Ni, if you want to measure how many species I has been, I means let's say the number of persons, how many number of person has been passed through accelerator when as an observer you are stationary. So how many person has been passed through accelerator? So there is also role of accelerator, yes or no? Because suppose, let's try to understand. It is just much more interesting thing is there to clearly. Just like accelerator is there, and here accelerator is moving with some velocity. Let's say 2 meters per second. This is the velocity of accelerator, and here some person is there, and these persons are also moving with some velocity. The person is also moving with some velocity. Clear? And as an observer, you are here, and they are the persons which are going to pass. So if you want to measure the characteristic feature of the person only, so how many person has been crossed from initial point to final point by its own nature, not due to ability of, let's say it's only be ladder, there's no accelerator is there, then what happen? Then only if ladder will be stationary, if accelerator is not moving, then only you are able to measure the characteristic feature of the species, yes or no? Working ability, if you want to measure the working ability of the species, then the accelerator must be stopped, yes or no? But if accelerator is moving with some speed and the person is also moving with some speed, then obviously you are not able to measure the characteristic feature of a species. Why? Because in that case, although the person is not moving, but still they are transporting here. Person's individual effort is not there, but still they may transport from one point to other point. So the person is going to transport not because of its own characteristic feature, rather than it's because of accelerator speed, yes or no? Please tell me. Are you getting a point? So which flux will define the characteristic feature of a species? At the same time, in second case, when as an observer you are also standing on the accelerator, which is moving with the 2 meter per second. Now in this case you are only able to measure what is the walking ability of the person which are going to pass, yes or no? So if you want to measure the characteristic feature of the species, then you must go for GI, because GI in NI there's two contribution is there. If I'm talking about NI is also called as total molar flux. Listen, NI is also called as total molar flux. Total molar flux. Why total molar flux? Because in this types of flux, the contribution is because of two. One is diffusive, means one is because of characteristic feature of the species, plus what? Bulk contribution. Bulk is also moving. Are you getting point? So first of all, are you getting NI and GI? So in NI is the flux of species I with respect to an stationary observer. But when the observer is stationary, you know? For example, again one more example I would like to give you to clear this topic. A fisherman is there. A fisherman is most interested in the rate at which the fish swims upstream against the flowing current to reach his baited hook. Means hook is there, and here fish is swimming here. Let's say this is the fish here, and hook, the fisherman has placed the hook to catch the fish. So as far as fisherman, suppose you are a fisherman, so you are more interested in the rate at which the fish swims upstream against the flowing current, yes or no? To reach his baited hook, and that's called as NI. Why? Because the fish is swimming, but also there is roll off. So the fish is coming, the rate at which the fish is coming to the hook is not because of only the fish feature, only to fish speed, but also there is roll of what? Also there is roll of current which is moving, the water which is moving. But if I am talking about the velocity of the fish with respect to the stream is analogous to J. The velocity of the fish with respect to the velocity of the fish relative to the stream velocity is analogous to J. So because when I am talking about the velocity of the fish with respect to the water or stream, means we are only going to bother about the characteristic feature of what? Fish, and this is analogous to J. Is this clear? NI and J is clear? So what is NI, what is GI? In NI, we are going to bother about a total contribution. Means just like I one more very simple example. Suppose if you have ever visited to the Delhi metro station, DMRC, Delhi metro. If you have ever gone to Rajasthan, there's too much crowd is there. You know? And suppose you are inside the metro and you don't want to deboard on the Raju metro station. But when the bulk is going to move, when the person in the most of the person which has been deboarded, which has been boarded in which are inside the metro station and they want to come outside the Raju Chowk station from the metro, then bulk is moving. That's why you have come out. Your contribution was not there, huh? Your individual contribution. You don't want to deboard on the Raju metro station. But as the bulk is moving, you may get transported from one point to other point. Just like here, as the accelerator is not moving. Suppose, sorry, here the person is not moving actually, but the accelerator is moving. That's why the person has been transported from the one point to the other point. So there is no any contribution of in the species. Clear? At the same time, suppose you are on Raju metro station. You are in a crowd area and you want to go from one point to the other point. So in that case, try to understand. You are in a very crowd area, and you want to go from one point to the other point, one stop to the other stop. So obviously you want to go here. You want to go from one stop to the other stop, but your contribution was already there. But along with your contribution, since whole crowd was moving here and there, so their role you can't ignore. Their role may also there. Yes or no? In total transport, in your movement from the one stop to the stop, only your contribution was not there. Along with your contribution, also the contribution of what? Bulk was there. Yes or no? So as an observer who is stationary at some reference frame, suppose there in a whole crowd area, one police barrier is there. In police barrier, one police was observing you. So as an observer, as a police who is observing your movement, for whom whatever the speed, whatever he is going to observe, he is not going to observe only your speed, your contribution. He is observing combined contribution of your movement. One, it's your individual contribution, and another is what? Bulk contribution. Is this clear? But as for a policeman, if he want to know only your contribution, he must also be in the crowd area. He must also be in crowd area. Then only he can be able to know what is actual contribution, what is your contribution in movement from one point to the other point. Is this clear? That's what is GIE. So in GIE, the actual species contribution, actual characteristic feature of the species, you can only observe with which flux? GIE. So GIE is the flux of species I with respect to moving observer. When the observer is moving with the same reference frame, with some reference average velocity, then only you are able to observe the characteristic feature of the species. Is this clear? But when observer is stationary, as far as stationary observer is concerned, he is going to observe, he is going to track the combined feature of movement, combined feature of transport. One is bulk transport, another is your individual transport. Clear? It is very clear. Now is this clear? No, I think it is enough to clear the इसके अंदर क्या है? Satya, clear? And that's why Ni is called as total molar flux. Why total molar flux? Because it is a actually, yes, you can say it's actually equal to the average velocity of the molecules. Average velocity of every molecule that present in the system. सत्या क्लियर है? as far as why Ni is called as total molar flux, because it involves both the contribution. One is bulk contribution, other is individual contribution. So please write down here, Ni is the flux of species I. Please here you can add flux of species I with respect to stationary observer. And this is the flux of species I with respect to moving observer. Mix. Moving observer. Moving observer means the observer must be moved with the average velocity of the molecules. So as far as listen, Ni is called as flux, I told you already. With respect to stationary observer, and it is also called total molar flux. Total molar flux. Why? And this is simply called as, I can define Ci into Vi. Total molar flux can be defined as Ci into Vi, where Ci is called as molar concentration of species I in the mixture. This is scooter बोल रहा है. And Vi is called as velocity. Velocity of species I with respect to stationary reference frame. Means stationary observer. Velocity. We have measured velocity when the observer is stationary. So when I multiply Ci with the Vi, I got the flux. You can see what is Ci beta? Mole per liter. And what is Vi? Meter per second. Let's say mole per meter cube. That's meter cube. Mole per meter cube. And here it's a meter per second. If you multiply Ci into Vi, so this is what is mole per meter cube, and this is meter per second, and it simply become mole per meter square per second, and this is called molar flux. And why it is called as with respect to stationary? Because this is the velocity we have multiplied here. This velocity is actually velocity with respect to stationary reference frame. When observer is stationary, then we have measured the velocities. So Ci the concentration of species I in the mixture. When we multiply the concentration of species I in the mixture with the velocity of that species, we get the total molar flux. Wait. Let me mix. Clear, beta? Is this clear? Now, if Ni equal to Ci into Vi, then can I write this as a then what is Ji? Ji is nothing but Ci into Vi minus V star. So again the same thing here, concentration into velocity. But which velocity I have written here? I have not written the velocity with respect to stationary reference frame. Now this is called as Ci into Di actually, and where Di is called as Vi minus V star, and this is actually the velocity of the species I with respect to moving reference frame. And the reference frame we are moving with what? Yes, it's a relative velocity. Velocity of the species I with respect to it is called as velocity of species I relative to more average velocity of species. Average velocity of species I of species in the mixture. Clear to you? Or also called as diffusion velocity. This is also called as diffusion velocity. Clear beta? Also called as velocity of a species with respect to moving reference frame, and the reference frame is moving with which velocity? Average velocity. Clear? So Ni is total molar flux, while this is only called as diffusive flux. So my dear student, the two definitions I have taken. If let's say I told you Ji equal to nothing, it's Ci into Vi minus V star. Clear? Then if you open this, Ci into Vi minus Ci into V star, and Ci into Vi is nothing is called as Ni beta minus Ci into V star. This implies Ni is equal to Ji plus Ci into V star. Yes or no? So that's why it's called total molar flux of species, because this is involved the two sum. One is flux contribution due to individual diffusive flux, and that's called as bulk contribution. Two contribution in total molar flux of any species. The two contribution is there. One is bulk flow contribution. This term indicates you bulk flow contribution in total flux. Bulk flow flux contribution. Flux due to bulk flow contribution. And this is the flux due to difference in concentration, means that is because of individual characteristic of the species. The flux due to concentration gradient. Concentration gradient means due to what? Flux due to concentration difference, also called as diffusive flux or diffusive flux contribution. Diffusive flux contribution means any transport due to its individual property, individual features, that's called as bulk contribution. Clear to you? I told you na, just like similar to, if very simple to recall, if suppose you want to go from here and there, from one point to other point, then there is not only your contribution. Suppose you are an accelerator, you are also going to move, then your moving speed and plus moving of the accelerator, both will contribute to total flux of your position from one point to other point. Yes, no? So one is your individual contribution, other is contribution of the species. As an observer, you are moving from one point to other point not due to only your individual contribution, but also due to contribution of the accelerator. Both will contribute to the total molar flux as an observer. Clear to you? Where V star. How do you find the average velocity? Let's say if you have a mixture is there where 4 components are there. 4 species, 4 components are there. One is Ca, Cb, Cc and Ci. A, B, C, D means there are 5 number of components are there, like oxygen, nitrogen, helium, calcium. Oxygen, nitrogen, helium, argon, calcium. No, sorry, calcium बोल रहा हूँ. Oxygen, hydrogen, helium, nitrogen, like this. है ना? They're gaseous molecules and they contribute. Their concentration is Ca, Cb, and Cc and Ci. And if you want to find every molecules of A is moving with some speed, molecule B is moving with some speed, and if you want to find average velocity, then how do you find average velocity? It's simply called as summation of Ci into Vi upon summation of Ci. That is the formula for average velocity. Means V star, if suppose for binary mixture, means if in the mixture only 2 components are there, A and B, I can write V star as Ca into Va, Ca times Va plus Cb times Vb on Ca plus Cb. Clear? This is what is V star, average velocity. Then if you put in this equation, then Ni is equal to Ji plus Ci. V star is nothing, is summation of Ci into Vi upon summation of Ci. Yes or no? My dear student? This is what is Ji plus Ci upon total. What is this called as? Mole fraction. The concentration of molar concentration of Ci upon total molar concentration is called mole fraction. So it's called as Xi. And summation of Ci into Vi is nothing, Ci into Vi is Ni. Yes or no? So very important result I got here. Ni is nothing is equal to Ji plus Xi into summation of Ni's from I equal to 1 to N. Where N is the number of components present in the mixture. Clear to you? Any problem? So here bulk contribution means I am not saying that there is a macroscopic movement. There is no any microscopic movement beta. Bulk motion means the whole molecules are moving randomly. Due to random motion of molecules, some species may also transport. So for example, if I want to discuss with respect to molecules, then just try to understand here. If there are some molecules are there. So one, let's say this is the molecule, the black molecules I'm talking about A, and the white molecule is of the B. The 2 components there, A and B. The A is for dark and B is for the lightness. So in the binary mixture, this some molecules are there and some molecules are B's there. And if you want to find out so let's say if you want to find flux, let's say this is what area I have, a hypothetical area I have assumed here. This is any position is, let's say X. at this point I want to find out how much molecules of A is going to cross this area in given time interval. That's called as flux. So this line which has been crossed by the molecule A, that is called as flux in given area in given time. So my dear student, actually every molecules are moving randomly. So one is even though, listen, try to listen, even though there is no concentration difference is there, is no difference in concentration, still the molecules are moving because of molecular diffusion. What is molecular diffusion? Molecular diffusion is simply the random motion of the molecules by virtue of their thermal energy. Even though there is no difference in concentration is there, everywhere uniform concentration is there, still the molecules are moving randomly because of thermal energy are there. So even though there is no difference in concentration, still the molecules are moving. That's only because of bulk contribution. There is no any individual effort is there, na? It means that term is zero. Gi is called as any diffusion of species with respect to average velocity. Here in this case molecules are not moving, means relative velocity is zero. Relative velocity is zero. So molecules are actually not just like you don't want to go from one point to other point, but actually the crowd is allowed to go from one point to other point. Your individual, you don't want to go. Your individual contribution was not there because you don't want to go, but still you have transport from one point to other point because of bulk is moving. Are you getting point? For example, suppose you are going to swim in the water in the river and you don't know how to swim, but actually what happens when due to stream of water flow, due to velocity of the water, you may get transfer from one point to other point. So your swimming ability has not been measured. Na? Swimming ability, in this case there is no swimming ability. You don't want to swim, you don't want to know how to swim, but actually you are moving from one point to other point just because of flow of water. Are you getting? So that is only because of this is called as bulk contribution. This term is like this: bulk contribution, flux due to bulk flow contribution. When bulk is moving, that's why your contribution. What was how much in total contribution because of bulk flow? In total contribution, what is contribution due to bulk flow? What is contribution due to flow of river? But as an observer who is standing on the river bank of the river, and suppose in this case you also want to know, you also want to swim, you have also ability to swim, then your swimming ability plus the speed of the water is also moving. So both will contribute to total, yes, no? Then the total flux will be the sum of in your own contribution, and this is the contribution to the bulk flow. Is this clear? That's what I told you. This is the flux due to concentration gradient or diffusive flux contribution, and that is bulk flow contribution. So both will get sum to equal to total contribution, total flux. So in this case, what happens? If there is no difference in concentration, then which is zero? If there is no difference in concentration, then which flux is zero? J or N? If there is no difference in concentration, is the N zero or J zero? Na and J, which term is zero? Please tell me. Molecules are moving randomly because they are gaseous molecules. And everywhere uniform concentration is there of A and B. Now please tell me, which flux is zero in this case? Na or J? Yes, J is zero. Very good. But J0 doesn't mean ki Na is zero. J0 doesn't mean ki Na is zero. Why? Because Na is the sum of J plus Na plus Nb into Xa. Means individual contribution plus bulk contribution. So J is zero doesn't mean that Na is zero. Na is not zero. Yes. And my dear student, it would be never the case when Na will be 0 and J will be not 0. Why? Because if Na is 0, what does it means? Acha, I'm sorry for this. Please, I just want to repeat, I want to revert it back. What is the case when Na is 0? If Na is 0, that is also possible. I will show you it. My dear student, listen. Because, okay, one more thing. This is the first case clear. Second case, when the difference in concentration is there, means here more molecules of A is there this side. More molecules of A is there, and there more molecules of B are there. This side. And when we remove this partition, what happens? When we remove this partition, then obviously the molecules of A will move from high to low and low to high. Right? A will move from left to right and B will move from right to left. Yes or no? Please tell me. The molecules, as we remove this partition, because left side is only A, pure A, and right side is only pure B. When you remove the partition, then obviously the transport of the species will take place. And if you want to measure the only A, flux of A, Na, in this case, the total molar flux of A is because of both contribution or only one contribution? My dear student, in this case, the flux of A is because of both contribution. One is because of difference in concentration, and other is because of bulk flow. Because bulk is every molecules are moving. Yes, that is what J plus Na plus Nb into Xa. Clear to you? No, direction of flow is not from high to low. No. What is high to low? Sir, A will transfer from the left to right and B will transfer from the right to left. But not because of only, but also the bulk is moving. So some of the species also get transport due to individual characteristics and some contribution in total flux. Some contribution is due to individual characteristics and some contribution because of bulk flow. Both will contribute to total flux. Is this clear? And one case will also possible when Na is 0, means total as an observer who is standing away from this reference frame. When observer is stationary, for him it seems like that A is not moving anywhere. It is a case just like here. Just accelerator is there, my dear student, and your friend is here. He is moving with 2 meters per second in this direction, and the bulk is moving with 2 meters per second in this direction. What happened? Please tell me. And you, this is your friend. This is species I, and you are an observer here. You are an observer. You as an observer, what will you see for your friend? You found your friend is not moving anywhere else. He is only standing on the same speed, at the same position. Yes or no? Why? Because so in this case, Na means for standing still, yes, and it means you as an observer, you found Na equal to 0. Means there is no any species I is moving here. Why? Because both contribution will be counterbalanced. Which contribution? Individual contribution is counterbalanced by bulk contribution. Yes or no? So Na can be 0. So Na is 0 doesn't mean that J is 0. Are you getting the point? Just like here, J is 0 doesn't mean that Na is 0. Here, if Na equal to 0, it means J is equal to minus of Na plus Nb into Xa. It means individual contribution means diffusive flux is counterbalanced by bulk contribution. Bulk flow flux. Yes or no? They're counterbalanced. Mr. Ravitra, J is bulk? No, J is not bulk contribution. Na plus Nb into X is the bulk contribution, beta. Yeah. Counterbalanced, minus. They're counterbalanced. Very clear? So my dear student, if n is 0, doesn't mean that A is not transporting, A is moving. Now generally our perception is that if n is 0 means no A is transporting. No, A is moving actually. Here your friend is moving actually. But for an observer who is standing on stationary reference frame, for him it seems that he is not moving. Is this clear? But actually the contribution of species I was there, na? But actually he is not able to move any position because of its contribution is counterbalanced by the bulk contribution. Clear? Yes, is this very clear? So my dear student, be careful. If J0 doesn't mean ki Na equal to 0. And if Na 0 doesn't mean ki J equal to 0. Your perception should be very clear. Ki if Na 0, it means an observer, for an stationary observer, the flux is 0. But actually, the individual contribution is counterbalanced by bulk contribution. That's why for an observer who is standing on a stationary reference frame, for him it seems to be the species I is not moving. Clear? And if J equal to 0, J0 means if there is no difference in if suppose if your person is like here, in this case again you can, your friend is here standing, he is not going to move any position, his velocity is 0, but this is moving with a 2 meter per second accelerator. So in this case your individual contribution is not there, means diffusive flux is 0, but for an observer Na is non-zero because Na is because of bulk contribution. So J0 doesn't mean Na equal to 0 and Na0 doesn't mean J equal to 0. Is this clear? So today I told you the basic information about Na and J, and I just cleared this topic about through various examples. I think it's very clear because it is very important to clear between these two types of fluxes. So please tell me which flux is important for measuring the characteristic feature of the species. Characteristic feature, if you want to measure the characteristic feature of a species, then which flux is important? J, yes. And in design of equipment, which flux is important? Na. Why? Because in design of equipment, the total molar flux is more important. Because as far as fisherman is concerned, the fisherman is more interested about the rate at which the fish is coming to the hook. We don't want as a fisherman never interest on the individual species, the velocity of fish with respect to the reference frame, with respect to the stream velocity. Yes or no? He's interested about the rate at which the fish is coming, and the rate at which the fish is coming is what? Na. Is this clear? उससे कोई मतलब नहीं है कि फिश की एबिलिटी क्या है उसको बस उससे मतलब है कितने at which rate the fish is coming to the hook. So in design of equipment, which flux is important? Na. And clear? Thank you so much for today. I think you have enjoyed this. No? So today is 8th of November 2021. So we completed this first lecture. Thank you.